Back. Welcome, my dear students, back. This is your teacher, Dr. Osama Kashwa. And we will go now to another, this is the lecture number 4 in hypothetical testing. And we will go through some other points, like when we will use t-test. We talk about using z-test or z-tabulated and compare it with z-calculated. Now we will go to z to the t-test. Let me just first, before when we share here, to show where we are standing. We finished this example about the height and the nurses, and we have another example here also about how to use, see like the formulation of H0, and H1 means greater than 170. Okay, then we will go to the Z to calculate use Z, because we have sigma and at the n is 400, which is more than 30. For that reason, we use Z. Then we calculate, we compare between Z tabulated and Z calculated. Z calculated is 2.46 and Z tabulated is 1.64. So the calculated is greater than the tabulated, which means we will not accept H0 and we will accept H1. Like I told you before, as long as the value calculated is greater than the value tabulated, then you will reject hypothesis 1, hypothesis nil. You will reject hypothesis nil and accept hypothesis 1. But if the Z or T calculated less than T or Z tabulated, then in that case, you will accept H0 and reject H1. And these are some examples like what I said in the board here. You will train yourself in them to use how to use Z in all the on your considerations. Here we go. There is an example now. I will use the t-test. Before this, I used on the board here the z-test. But now I will go for an example of using t-test. And like I told you before, when we would use Z, look at the board here, like I showed you before, when we will use Z and when we will use t-test. If you have the standard deviation of the population and the sample is more than 30, then you will use Z-test. Then you will go to the tables of Z. If the sample is less than 30 and you don't have the standard deviation of the population, then you will use t-test, or you will go to detect or find the value in the tables of T, not the tables of Z. So we take the same procedures of doing the same thing. We take the same procedures of doing the same calculations, but we will also compare. That time we will use T instead of Z tables. Let me show you a small example quickly about this, and I will work on the board. But before that, let us read this example. We were told that we should use 0.5 significance level. We assume that each football player is independently tested, that their GPA is not related to another football player's GPA. Okay. He wanted to check out the relationship between the GPA of the football players. You want to check out their own how it looks like, how their own performance in the GPA because they're playing football. We have that assume that the sample is nearly normal. The sample is an indication of the population shape. The size of the sample also helps here, as we took 20 players. So N here is less than 30. In that case, we will use T. So we can conclude that assumption of the following. Uh, like here, X bar is 318 because the average in the population in the sample is 318, and the average in the society or population is 310, and we have the standard deviation of the sample 54, and we'll divide by the root n of the sample. It gave me 0.66. Okay, we will compare 0.66 with the value, the significance. Now when we look at the table, we'll look under 19 n minus 1. So they are 20. 20 minus 1, the sample means 19. With the degree of the significance of 5% in t-test, we will find this value, 2.093. Let me show you as example. If I have the t-table here, I will show you a part. Okay. You look under the degree, the numbers of 19, the degree of freedom 19. I have 19 here, okay. And under 5%, one tail, but this is for one tail only. It's not for two tails, okay. This is upper tail probability, okay. So 19, and about the what are you looking for? 2.861 we have, and 2.539 for 1% and 5%. So we will compare this value with the value here determined here, and we will see how it works, or what it when you compare it to each other, and see that 2.093 is greater than 66, which will mean that this area is the area of the acceptance, and you will accept H0 in that case. Here, an example. Duracell manufactures batteries that the CEO claims will last an average of 300 hours under normal use. Let us go to this example, and this is also, I believe, it's using t-test. Yes, it's using t-test. Okay. Okay, let's see it. The average of hours is 300. So let me stop sharing. Okay, and go to the example here, and we'll take from it a point by a point, like we used to do, we did in the past one. Okay. Now I have the let's check out our points which we'll work on, our points which we will work on now. Now, the first thing is that he's saying Duracell manufacturers batteries that the CEO claims that the average of 300 under normal use. So when we say, we will say H0 or H0, like we said before, this is the average of the society. So mu is the average of the society. Mu is the average of the society will equals 300 hours, because they said that the mu, or the average of the batteries working, look at this, the mu of the average working of the batteries is 300 hours. Okay, 300 hours, like you see here. Okay, so we said H0 mu will equal 300 hours. Let us go back and see one by one. One by one. Okay. A researcher randomly selected 20 batteries. Wait a minute. Wait. This is N. We call this N. 20. Sample of 20 batteries. So N will equal 20. Perfect, perfect, perfect. Then I will go here. Okay. And the sample here, I will put it on a side and write it here. N equals 20. I will put the data given here. Okay, so N is the sample, N is the sample. As I saw the sample is less than 20, 30, sample is less than 30, it's indicator that I will use t-test. I will use, instead of using z, I will go and discover the value in the tables of the t instead of the tables of z. Okay, now let me go for the, we are walking like this. Every line we take from it, something will help us uh, in the solution. Okay, a researcher selected 20 batteries from production line and tested these batteries. These batteries had a mean lifespan of 270. Hey. This is in the sample. So this is the average of the sample. The average of the sample is 270. Okay. Okay. So the average of the sample we use for it, X bar sample average. Let me write it and write it also. Average, sample average will equals 270 hours. So it's working 300 hours. That's in the start the piece. The people say the Duracell batteries work 3 hours, 100 hours. In general, it's working 3 hours. But when you came to see in the sample, he found that it's working only 270 hours, not working 300 hours like the people claim. Perfect. Perfect. Then, after that, let us share the screen back and see. They tested the batteries that mean 270 hours with a standard deviation of 50 hours. Oh, so the standard deviation this time is not for the population. The standard deviation this time is for the sample. For that reason, let me remind you, it is how many hours? 50 hours. Okay. S equals 50. Let me remind you something very small. We talked about it before. That we said the sample, the standard deviation, in the population, standard deviation ST, DEV of population will make it with this simple, like this way. This simple, okay? Sigma, we call it sigma. But standard deviation of the sample, we will give it this S for the sample. So the same standard deviation, but for the population, for the whole population, we call it sigma. But standard deviation for the sample, we call it S. So here, he's talking about the sample. For that reason, we said S equals 50. Yeah, it's like the same, like the other formula, but we will change the sigma with S. Because here we are talking about sample. The standard deviation in the sample is not the standard deviation in the population. So for that reason, we used S instead of sigma because it is related to the sample. Okay, now S equals 50. We'll go back and share the screen because I wanted line by line so that you will understand. They tested the batteries. Do we have enough evidence? Do we have enough evidence this is greater or less or unequal to suggest that the claim of an average lifetime is false? He didn't say greater than and he didn't say less than. For that reason, look at this. He made it unequal. Unequal, then I will say that this is hypothesis null. Then we said unequal. Unequal means hypothesis 1 or hypothesis alternate. We will make like this hypothesis 1, okay, mu unequal 300 because of the formulation and the context of the talk itself. What he's talking about, he said, is it different, the population of the society, the average of the population it the same like the average of the sample or no? Does it make difference? Does it make sense? But he didn't say, is it greater or less? If it is greater, I will make the greater sign. If it is less, I will make the less sign. But he said, it it doesn't differ or no? Does it differ or no? For that reason, we put the hypothesis, the alternate hypothesis, on that figure or in that shape, unequal or unequal. Okay. I guess everything we have now. We can do our test now. So we said, formulating the test, formulating hypothesis, the first step on the hypothetical steps, they are a protocol. The first step on the protocol is just to put the hypothesis Z, null, and hypothesis 1. And that's what we did here behind me. Here, we did hypothesis null and we did hypothesis 1. Okay. Second step is to use our test. I will use the test. The test tool here, test, because we don't have the value sigma of the standard deviation is unknown. Standard deviation sigma is unknown. And sample is less than 30. Because, again, because the standard deviation of the population is unknown, okay, of the population, and the sample is less than 30, then we will use T test instead of Z test. We will use T test instead of Z test. Okay, we will use T instead of Z. Okay, so now we will use T. How we will use T test? The same. We'll say T equals X bar minus mu divided by, there on the previous one we said X bar minus mu divided by sigma divided by the root of n. But we said we don't have sigma of the population here. We have sigma of the sample. So we said S, like I told you here, S. We will use S instead of sigma because I don't have the standard deviation of the population divided by the root of n. What is the root of n? The n here equals 50. The n here equals 50. So what? So this will equals for me, when you substitute X bar is 270. This will equals 270 minus mu is 300, minus 300, divided by S equals 50, divided by the standard deviation, the root of the sample. Sorry, the S is what? The S, I'm sorry. The S is, 50. And the sample is 20. Here is 50. And the sample, the root square of, this is 20. 20. Okay, so here we go. X bar is the average of the sample. The average of the sample is 270, is given. Mu is the average of the population. The average of the population is 300, divided by sigma. But sigma this time is for the sample. For that reason, sample, divided by the root of n. So I have the root of n. The n, he told me the n is 20. And I use the test here for two reasons. Because I don't have the sample, the standard deviation of the population, and at the same time the sample is less than 30. That's why I use T test. I will use here T test because of that. Okay. Then that all will comes to, let us see, when you finish your calculations in this, T will equals then So T will equals, when you finish all this, 270 minus 300 divided by 50 divided by the root of 20. Let us see in the example how much it is. Okay, that's come to 2.68 minus 2.68. Okay. Minus 2.68 will equals minus 2.68. I said before the minus is nothing. Don't worry about the minus, positive or minus, because the normal distribution curve area is the same. So it only show you, just neglect, discard the minus. Minus only will show me where is the direction of the test, to the left or to the right, because it's one tail. So when it's minus, it will go to the left. When it's positive, it will go to the right. This is the only difference. Minus will go like this way. When I'm, okay, let me show it to you. Here, when it is minus, I will check this area. But if it is positive, I will check the other area. If it was positive, if this was positive, then my test will be on this area. So the negative and positive tell me if you will test the right side or the left side. The negative and the positive will tell me if I'm testing the right side or the left side. Okay? Okay. So here we go. So it's minus 2.68. Now this is the first one. Hypothesis null, putting the formulas or putting the hypothesis, using the test. Then we use the test. Then after that, compare. T tabulated with T calculated. I will compare the T tabulated with the T calculated. How I will do this? I have now the T calculated. T calculated, CAL means calculated, equals minus 2.68. Perfect. T tabulated, how I will get the T tabulated? Now I will show you how much is the sample. The sample is 20. I will calculate something is called degree of freedom. Degree of freedom will equals n minus 1. Will equals n minus 1. Will equals, the n is 20. The n is the sample. Sample minus 1. Then will equals 19. Then will equal 19. So here it will be 19. Okay. And the degree, we see the confidence. So degree of freedom, I will look on the table for degree of freedom equals 19, and alpha is how much? Let us see alpha. Alpha, it will be given in the example. Alpha will be given in the example. So let's see alpha in the example for how much? It shows, see, alpha is 5%. Alpha is 5%. Alpha is 5%. Okay. Okay. Alpha is 5%. So we will look on T table. We will look in the T table. We will go to T table and look. We will go for T table and look where the degree of freedom, DF, is 19. What is the 19? N minus 1. What is the N? N is a sample. Sample minus 1 will equals 19. And alpha equals 5%. It's only one tail test. It's a two tails test here. Two tail test because of what? Because of what? Because of unequal. Two tail test. Two tail test. Perfect. I will go to look in the table now for this. And the value I will put it here. The value of T tabulated, I will put it here. Perfect. Now let us go and see the table. Let us go and see the table. I will show you the table here of T. Here is a table of T. This is Z, sorry. I will show you. Here is a table of T. We are looking under table 19, 19, degree of freedom 19, will go down to 19. Then we will go for alpha 5%, alpha 5%, but this is one side. But here it is two sides, which is 0.025, because you will divide this 0.5 by 2. It will give you 0.025. So you will look under the point 2.093. This is the T tabulated. Again, again, again. This is the T tabulated now. We go for the degree of freedom, which is n, the sample minus 1. Sample is 20. When we deduct 1, then we will look for 19. We'll go down till 19 here. Here we go. This is 19. Here, this is the 19. And at the same time, the degree of freedom is alpha 5%. 5%, 2 tails means 0.025. Why? If I divide 5% by 2, because it's 2 tails, I will not, this is only 1 tail, if it is 1 tail. But here, because of unequal, it makes it 2 tails. So I will look under 0.025. 0.025 goes down with 19 and see, check out for the value. 0.025 and check out for the value. And the value, like you see here in front of you, is the calculated 2.093 of the significance of 2 tails, 2.093, 2.093. Let us see here, 2.093 on 19, 2.093. Here we go. Under 0.025, like I told you, 2.093. Okay, 2.093. Let us see it back. Then T tabulated, I will write it in the red, 2.093. Now you can see from here. Now you can see from here. I put it here, the T tabulated, which we saw in the table, not just now, 2.093. Perfect. I have the calculated, and this is the tabulated. Last thing, when we compare the step number 4, compare, or this we're still comparing, then we find that T tabulated is less than, because this T 2.0, but this 2.6. T tabulated, or T calculated, we can say T calculated, I think I have to write with black, that's fine. We find that the T calculated is greater than the T tabulated, because T calculated is 2.6. T calculated is greater than T tabulated. Don't worry about the minus and positive. It's compare a number with a number. Again, discard the minus sign. So you will compare T calculated the numbers, just abstract numbers. Okay, don't worry about the minus. 2.68, the calculated, and the tabulated is 2.0, because, okay, it's like this one is greater. So T calculated is greater than T tabulated. As long as the calculated is greater than the tabulated, then reject decision, we'll write decision, the last thing, decision, due to t calculated is greater than t tabulated, then we reject H0 and accept H1. We reject H0 and accept H1. And when you want to do this, let me show you something. Let me show you something. You will make your graph, and this is the middle, and you have the t calculated minus 268. This is the t calculated here, minus 268. As example, here it is. It will be out of the area. Okay, the area of the acceptance for us here, for accepting H0 in this area, accept H0. Accept H0 in this area. To accept H0, let me grow it, make it larger than this. Let me make it larger so everyone can see. Okay, now how we can do this? Here in the graph. Okay, I want to accept the tabulated is the area of the acceptance. So if we say here in the middle or the 0 point, and I'm moving forward to the left, here is to accept till the tabulated. The tabulated is 2093. Tabulated is 2.093. This is the tabulated. Here we accept H0. Okay? As long as the t calculated is more, that means it's here. The t calculated is more, that means it's in this area here. Because it's out of this range. It's more than this range. So this is the calculated is here. The calculated is here in this area, which means if I accept H0 here, then here the opposite, I will reject H0. And that's what we said. Okay, we reject H0 because we are out of the area of accepting H0. We are out of the area of accepting H0. We are in the area of accepting H1 or rejecting H0, the opposite. Because the t calculated is greater than the t tabulated. T tabulated, you can accept H0 till 2.093. But here it is more. It's 2.6 more. So it's out of the area of acceptance. It's more than the area of the acceptance. It's out of the borders of the area of the acceptance. That's why we rejected, and this is our decision in that case. And based on this is the answer of the question. This is the in simple. This is when we will use the t-test. We knew when to use the t-test. We use the t-test if the sample is less than 30 and the standard deviation of the population is unknown, and I have instead only the standard deviation of the sample. In that case, I use t-test. We use t-test is more complicated just a little bit because we have to calculate the degree of freedom. Degree of freedom is the number of the sample minus 1. This we call it degree of freedom. Plus, we will go to the, is it one tail or two tails? One tail, 5%. We directly will look down one tail, 5%. Two tails, 5%. Then you will divide 5% by 2. It will give you 0.025. Then you will look on the column of 0.025 for the value of this amount. This is another example for t-test also, actually, like that way. Okay, and yes, so here we go. See, since our calculated t-test value is outside of our critical value, is lies in the critical region, we reject the null hypothesis, like we said, and we accept H1. We reject a null hypothesis. Here, we reject the null and accept H1. So you always look at the numbers without the signals. Don't worry about the signals. You look only for the numbers. If the number of the calculated is greater than the tabulated, then you are out of the area of the acceptance, and you are in acceptance of H0. Okay? It's when you repeat the video once, twice, three times, then it will come to your consideration that it will be. This is about the when we have in ratios, about which we have ratios. So the example of the ratios is very easy also, very easy, because it show me it's very easy one, and I will give it on the next video. I'll make a video for the proportions, how we would calculate the proportions, or Z test for the proportions. Okay, and that will be fun. Thank you so much. Enjoy your day. Thank you. Wait for the next video. Thank you so much. Bye bye.